Hello students, welcome to digital classes. In this session we are going to learn tangents and secants chapter. By the end of the session we are going to learn definitions of tangent and secant to a circle, construction of a tangent to a circle, and also construction of the pair of tangents to a circle from an external point. First let us recall what is a circle. Students, what is a circle? All of you know the circle is nothing but a set of points at a fixed distance from a fixed point on a plane is called the circle. What is a circle? A set of points at a fixed distance from a fixed point on a plane is called the circle. Let us see, this is a circle which is having center as O and OA is a radius. Now the fixed point O is called the center of a circle and fixed distance R is called the radius of a circle. That means for every circle we are having center and radius. So center is a fixed point which we generally denote it by O and the radius is R. Radius we denote it by R. Now let us see some definitions of the circle. The first one is chord. So what is a chord? We have learned in the 9th class or previous classes. The chord is nothing but the line segment which is touching 2 points of the circle. The line segment which is touching 2 points of the circle is called the chord of a circle. So if you observe in this diagram, this is the line PQ. PQ we call it as a chord of the circle. Now what is the longest chord? The diameter of a circle is the longest chord of the circle. So always the longest chord is nothing but the diameter is called longest chord of the circle. So what is a chord? Chord is nothing but the line segment which is touching the 2 points of the circle is called the chord and the longest chord is called diameter, and we denote diameter by 2r. D is equal to 2r. D is nothing but diameter. Diameter we will always say D is equal to 2r. If you observe in the diagram, RS is a diameter. Diameter D is equal to 2r. And also we can say the diameter is the chord passing through the center of the circle is called the diameter. The chord is nothing but the line segment which is touching 2 points is called the chord, and diameter is the chord passing through the center of the circle is called the diameter. And next let us see one note. The length of the chord will increase if it moves towards the center. That means if the chord is moving towards the center, then the length will be increasing. Vice versa, if the length of the chord is decrease if it moves away from the center. So the length of the chord depends on the distance from center to the chord. The length of the chord will increase if it moves towards the center. The length of the chord will decrease if it moves away from the center. Now let us see the relation between a line and a circle. Now this is a circle having center O and this is a line. So if you observe this line and circle, both are not touching each other, and PQ is a line here, and the second one, the circle having center O and the line passing through the circle which is touching at 2 points. One is at A and one is at B. So AB is called chord and PQ we call it as secant. If you observe the figure 3, there is a circle with center O and this is a line PQ line which is touching a circle at only 1 point. So if you observe the figure 1, 2, 3, in the figure 1 what we can say, the line PQ and the circle have no common point. In this case PQ is a non-intersecting line with respect to the circle. So in the figure 1 what we can say, the line PQ and the circle have no common point. So in this case PQ is a non-intersecting line with respect to the circle. And if you observe the figure 2, the line PQ intersect the circle at 2 points A and B. It forms a chord AB on the circle with 2 common points A and B. In this case PQ is called secant of the circle. So first one, there is no common point. In this second figure, two common points are there, A and B. So PQ is called secant of the circle. That means a line which is passing through the circle is called the secant of the circle. A line which is passing through the circle is called the secant of the circle. And if you observe the figure 3, there is only one point A common to the line PQ, and the circle, the line PQ is called tangent of the circle. So in the figure 3, there is only one point A common to the line and circle. So the line PQ is called tangent of the circle. So what we can conclude with this? The first figure, no common point, and the second figure, two common points, and the third figure, only one common point. So if two common points is there, the straight line is called as a secant of the circle, and if only one common point is there, then we can say that line is a tangent to a circle. We can say the circle and the line. If the line is passing through the circle, then the line is called secant of the circle. If a line is touching to the circle, then the line is called tangent of the circle. So this is about secant and tangent. Now let us see about tangents of a circle. So the word tangent comes from the Latin word tangere. The word tangent comes from the Latin word tangere. Tangere means to touch. It is introduced by Danish mathematician Thomas Fineke in 1583. Now let us see what is tangents of a circle. So in the tangents of circle, this is a circle with center as O, and this is a line which is a tangent. PQ is a line which is a tangent which is touching the circle at A. So if you observe, what is a PQ here? Students, PQ is a tangent of a circle, and what is A here? So here the new word will come. A is a point of contact. So here A is a point of contact. So what is a point of contact? So the point of contact is nothing but the common point of the tangent and the circle is called the point of contact. The common point of the tangent and the circle is called the point of contact. So PQ is a tangent here. This A is called point of contact. Now the tangent is said to touch the circle at the common point. So always the point of contact is nothing but the common point of both circle and the straight line. So which is called tangent. How many tangents can be drawn to a circle? The answer will be infinity. Why? Because on the circle, how many points will be there? On a circle, there will be infinite points on the circle. So from each point we can draw a tangent. So how many tangents we can draw? We can draw infinite tangents to a circle. So the tangents will be infinity. From each and every point on the circle, we can draw a tangent. So these are all the tangents to a circle. From each and every point we can draw a tangent. So we can draw infinite tangents to a circle. Okay, now let us see the construction of a tangent to a circle. So how to construct a tangent to a circle? Draw a circle with radius 4 cm and construct a tangent to it. So what is the question here? Draw a circle with radius as 4 cm and construct a tangent to it. Now construct a tangent to a circle with radius 4 cm. So for construction we need to write a construction steps also. So what are the construction steps for it? First we need to draw a circle with radius is 4 cm. Let us draw a circle. First construction step is draw a circle with radius as 4 cm, and now I am taking a center as O and the radius as 4 cm. I will draw a circle now. OA is 4 cm, and from O as center, OA as radius, I am drawing a circle which is a circle with radius 4 cm. Now extend OA to B such that AB is equal to radius. So now whatever OA is there, I need to extend OA to OB such that AB is equal to 4. So whatever the radius is there, the same length I have to extend it. So now OB is a line which is having 8 centimeters. Now draw a perpendicular bisector XY to OB which passes through O. So now how to draw perpendicular bisector, all of you know, students. So from O take more than half, one arc upside and one arc downside. From same take B as center, cut the previous arcs at X and Y. Now let us say this as X and this point as Y. X and Y. Now join X and Y. So joining X and Y which passes through A. So this is the perpendicular bisector of OB which is passing through A. Now the line XY is a tangent to given circle. So what are the steps, students? Once again let us see. Draw a circle with radius as 4 centimeter, and next one is extend OA to B such that AB is equal to 4 centimeters which is equal to radius. Now the perpendicular bisector of OB, all of us know how to draw the perpendicular bisector. Take O as center, take more than half, draw an arc upside downside, and take B as center with the same radius, cut the previous arcs which cuts at X and Y. Now join XY which passes through the point A. So the line XY is the required tangent to the circle. Okay students, let us see angle between tangents and the radius at the point of contact. So this is the circle, this is the tangent, and A is a point of contact. And now another circle, same I can take tangent. So OA is the radius. Now the relationship between the tangent and the radius. So always the angle between the radius and the tangent is 90 degrees. So this is the 90 degrees. The angle between radius and the tangent at the point of contact is always 90 degrees. So we can say from the theorem 9.1, the tangent at any point of the circle is perpendicular to the radius through the point of contact. So wherever the tangent and the radius meets at the point of contact, always the angle is 90 degrees. So next let us see the converse theorem of this. The converse theorem is, if line in the plane of a circle is perpendicular to the radius at its end point on the circle, then the line is tangent to the circle. If a line in the plane of a circle is perpendicular to the radius at its end point on the circle, then the line is tangent to the circle. We can say one note here, the line containing the radius through the point of contact is also called the normal to the circle at the point of contact. If you observe this, this is the line which is the perpendicular to the tangent. The line which is perpendicular to tangent is called normal to the circle. Now let us see how to find the length of the tangent. This is the circle having center O, and this is the tangent. PQ is a tangent, A is a point of contact. Now the example is, find the length of the tangent to a circle with center O and radius is equal to 6 centimeters from a point P such that OP is equal to 10. So this is the radius is 6 centimeters and OP is 10 centimeters. Solution. We know tangent is perpendicular to the radius at the point of contact. From previous theorem, what we know? Tangent is perpendicular to the radius at the point of contact. Here PA is a tangent segment and OA is the radius of the circle. So what is OA length? OA is the 6 centimeter and OP is the 10 centimeter which is given in the problem. Now let us see. Now we need to find out the length of AP here. AP is the tangent. We need to find out the length of tangent AP. So we know that OA is perpendicular to AP or PA and OAP is equal to 90 degrees. Now in triangle OAP, this is the triangle OAP, right? In the triangle OAP, which is a right angle triangle, by Pythagoras theorem we know that the hypotenuse square is equal to side square plus side square, which is OP square is equal to OA square plus AP square, and we know OA value and OP value. Let us substitute here. OP is a 10 square and OA is a 6 square plus PA square. So 10 square is 100, 6 square is 36 plus PA square. Let us send 36 to left hand side. So PA square is equal to 100 minus 36, which is 64. So PA square is equal to 64 is nothing but PA is equal to how much? It will be 8. So 8 is a required length of the tangent. So we can say the length of the tangent PA is equal to 8 centimeters. So this is the way to find out the length of the tangent. Because OAP is a right angle triangle, by using Pythagoras theorem we can say hypotenuse square is equal to side square plus side square. So by using this, if any of two sides are given, the third side can be find it out. Now let us see number of tangents to a circle from any point. This is a circle O and this is a point which is inside the circle. So if a point is inside the circle, can we draw any tangent? So this is not a tangent. What is this, students? This is secant. So from a point which is inside the circle, we cannot draw any tangent. So I can write like this. In the case 1, there is no tangent to a circle passing through a point lying inside the circle. If a point lying inside the circle, so we cannot draw any tangent to a circle. Now let us see if a point is outside the circle or on the circle. The second case, let us see, this is the point which is on the circle. So case 2, there is one and only one tangent to a circle passing through a point lying on the circle. So we can draw, there is one and only one tangent to a circle passing through a point lying on the circle. So if the point is lying inside the circle, we cannot draw any tangent. If a point is lying on the circle, we can draw only one tangent. Let us see one more case, point lying outside the circle. So this is the point outside the circle, so we can draw one circle like this and one more tangent like this. So there are exactly two tangents to a circle through a point lying outside the circle. So if you observe here, the point is outside the circle. If a point is outside the circle, we can draw two tangents. So finally what I can say, if a point lying inside the circle, no tangent can be drawn. If a point lying on the circle, we can draw only one tangent. If a point is outside the circle, we can draw two tangents. Conclusion is, if point lies inside the circle, how many tangents? No tangents can be drawn. If a point lies on the circle, only one tangent can be drawn. If point lies outside the circle, two tangents can be drawn. Okay students, now construction of tangent to a circle from an external point. So how many tangents we can draw from an external point? We can draw two tangents from an external point. Let us see the construction. First, the problem is, draw a circle of a radius 6 centimeters from a point 10 centimeter away from its center. Construct the pair of tangents to the circle. So first let us understand the question first. Draw a circle of radius 6 centimeter. That means first we need to draw a circle with radius 6 centimeter. Now from a point 10 centimeter away from its center. That means the point P is outside the circle. That means we can draw two tangents. So construct the pair of tangents to the circle. Draw a circle of radius 6 centimeters from a point 10 centimeter away from its center. Construct the pair of tangent to the circle. Now for this we need to draw even rough diagram also. So steps of construction is, first draw a circle with radius as 6 centimeters. So now I will take radius as 6 centimeter. From point this, O is a center and radius is 6 centimeter. With the scale I am drawing a radius 6 centimeters. Now OA is a center, drawing a circle which is a circle of radius 6 centimeter. Now take a point P which is 10 centimeter away from the center. So this is a point P which is a 10 centimeter away from the center. 4. Total should be 10 centimeter. Now join OP. So OP is 10 centimeters. Now draw perpendicular bisector of XY of it. So how to draw the perpendicular bisector? You know that. From O, more than half, arcs up and down. Now from P, cut the previous arcs. Cut the previous arcs. The radius should be same. The joining points are, consider it as X and Y. So this point is X and consider this point is Y. If I join these two, X and Y, so this XY is the perpendicular bisector of OP. Now let M be the midpoint of OP. So this is this point will be M, right? M is the midpoint of OP. Now M as center, take M as center and PM or OM as radius, draw a circle. M as center, MO or MP radius, draw a circle. So this is a circle which intersects the previous circle at 2 points. So the intersecting points are, let A is a one point and B is another point. Observe students, the new circle is intersecting previous circle at 2 points A and B. Now join A and P, join PA and PB. So which are required tangents? So PA and PB are required tangents. So let us see once again students, steps of construction. First draw a circle with radius as 6 centimeters. So whenever you are writing construction steps, you need to draw even the rough diagram also. So for rough diagram also you will having marks students. So draw a rough diagram here. So the next step is take point P which is 10 centimeter away from the center. So join OP. So OP will be 10 centimeter. This will be 6 and this is a 4. Total should be 10 centimeter. Now perpendicular bisector. From O draw a line. From O draw an arc up and down. Same from P with the same radius. Cut the previous arcs which is X and Y. Now join XY is the perpendicular bisector of OP which is passing through M. So this is M is the midpoint of OP. Now from M draw a circle taking the M as center and MO or MP as radius, draw a circle. So which cuts the previous circle at A and B. So these are the points are most important students. From this point A, draw a line, join PA and also join PB. If you observe, there are two tangents to the given circle. This is our given circle and PA, PB are my required tangents. Okay students, the lengths of tangents drawn from an external point to a circle are equal. So let us prove this. So this is the two tangents. So all of us know at point of contact the angle is 90 degrees. So 2 point of contacts here. So then 290 degrees. P is an external point. So we know that given a circle with center O, P is a point lying outside the circle and PA and PB are two tangents to a circle from P. So this is a tangent PA and this is a PB. So what we need to show, the length of the tangents drawn from an external point to a circle are equal. That means from this external point, two tangents, one is a PA and one is a PB. We need to show these two are equal. What we need to prove? PA is equal to PB. So to prove PA is equal to PB, what you need to do is join OA, this is OA and OB and OP. If you observe here, OAP is 90 degrees and OBP is also 90 degrees from the previous theorem. Now in the two right angle triangles, here what are the two right angle triangles? OAP is a right angle triangle and OBP is also a right angle triangle. What we need to show? We need to show AP is equal to AP. For that what I am doing is, I will show these two triangles OAP and OBP are two congruent triangle. Then from triangle OAP and OBP, if you observe, OA is equal to OB. Why OA and OB are equal? Because OA is a radius and OB is also radius. So the radius of any circle always equal. So I can say radii of same circle is always equal. Now OP. OP is a common side, right, for both OA and OP, OAP and OBP. So I can say OP is equal to OP, which is a common side. Therefore, by RHS congruency, what is RHS congruency? This is a right angle triangle and hypotenuse is hypotenuse and side. Both, this is a hypotenuse, right? OP is a hypotenuse. Hypotenuse is equal and also one side is equal. Then by RHS congruency axiom, we can say OAP is a congruent to OBP. OAP is a congruent to OBP. This gives PA is equal to PB. So how we have proved, students? First we have joined OA and OP. So there are two triangles formed, OAP and OBP. So from OAP and OBP, OA and OB both are equal because both are radius, and OP is a common side. So by RHS congruency, these two triangles are congruent to each other. So I can say by CPCT, PA is equal to PB. So therefore I can say two tangents lengths are equal. So hence it is proved. So always the tangents drawn from an external point are always equal. Okay, students. Now try yourself. There are problem. Construct a tangent to a circle whose radius is 4.5 centimeters. Try yourself, student, this one. And next one is construct the pair of tangents to a circle whose radius is 4 centimeter from an external point which is 10 centimeter away from the center of circle. First one is a one tangent and second one is a pair of tangents. Try these problems. What we have learned, students? We have learned definitions of tangent and secant to a circle, and also we have learned construction of a tangent to a circle, and we have learned construction of the pair of tangents to a circle from an external point. In the next class, we are going to learn the next topic of the tangents and secants of the circle. Okay, students? Thank you very much.